will be Juho Raukola. Juho Raukola is an innovation expert in Wärtsilä Corporation and is the main specialist in the area of additive manufacturing within the company. He is responsible for forming and implementing utilization strategy of additive manufacturing technologies in the company and building up a global additive manufacturing ecosystem for supporting current businesses and creating completely new value chains in the marine and energy sectors. Please welcome Juho.
Hello, good afternoon. So as said, my name is Juho Raukola, and I work as an additive manufacturing innovation expert in Wärtsilä. I'm based in Vaasa, Finland, in the western coast. In this speech, I will address the effect of additive manufacturing to the advanced high-level simulation-based design process of products in near future, but also the impact of how we do things in very concrete way already today, utilizing the characteristics of additive manufacturing and basically the design freedom of it. A couple of words about our company, Wärtsilä. We are a global player in the area of marine technology and energy technology. We have almost 20,000 employees globally and revenue about 5 billion euros annually. We are divided into two main business units. Marine Solutions, which is operating basically on the whole scale, area of marine business and everything which is related to the ships. And for example, Wärtsilä has some operations or some technology in 1/3 of vessels and ships globally. And also we are servicing half of them, so that we have pretty good coverage. And in our energy solutions, we have installed base of around 17 gigawatts, which is equivalent approximately a couple of thousand of John's computing units. So we can run them. It's not a problem for us. And we have been also trailblazing introduction of gas engines, big 4-stroke gas engines in the energy production. And also, even though we think that we are an engine company, at least we do in Vaasa, we are an engine factory, but the engine, okay, it's huge. As you can see, there is a human to get the scale. It's like 100 tons. It's pretty big. But it's still a tiny part of the whole system we want to build. So we have still engines there, but there is a couple of other things also. For example, navigation, propulsion, pumps and valves, things like this. It's a very, very complete offering. And as it said there, it's like the most complete offering in the world. And this provides us a better view to actually provide a better value for the customer, because we have integrated the system instead of like just providing one subsystem and making it good. We make the whole system good. Find the synergies. Okay, a couple of words about additive manufacturing, which is also called 3D printing. It's a manufacturing method which is based on layer-by-layer principle. So that, based on the 3D model, we build up really thin cross-sections of a geometry and eventually come up with a ready-made part in a one shot. And we are starting from scratch. It is toolless technology, which means that we are not transferring any geometry to the workpiece, but instead we grow it. So that it means that we don't have the conventional limitations which are related, for example, casting, cores, molds, and also machining, because you have the tool. It has some kind of like a form, like a geometry. You're just inserting that geometry in the workpiece and subtracting material, whereas we are adding material here. Due to this, every part can be unique, and it's only a matter of design and 3D models, how many of different designs we can do, since it's not dependent on any physical tools. It's really something different. This method definitely have some kind of limitations, but still, it's a very powerful tool alongside the conventional methods, such as casting and machining. All right, digital equals exponential. What does that mean? This is one of the most trickiest slides. Try to hang on. I will go through this. We will get to the concrete solutions then. Why is digital exponential? John said that, yeah, in hardware, it's actually not, but I'm talking more about the applications, and they are. Since it speeds up communication, it shortens the cycle time. For example, iterations needed in simulations. We can do multiple instead of one, so that we end up with better answers. Also, it will increase the available data and also the quality of data, because it enables us to analyze the data in a way that has been never ever before possible. And also, the importance of open source, this kind of copy and paste solutions. They can be considered as Lego bricks. You just put them next to another, and then you have a ready-made solution, only tailored for you. Additive manufacturing is inherently digital, which means, as I said, it's based always on 3D model. No manual phases of manufacturing itself is needed. Everything is transferred to the digital thread. This means also for CAE, for example, and CAD system, 3D modeling system, the connection is seamless. There is no losses between that. With 3D printing, the geometries can be really complex, because it doesn't matter, since every single part is unique, the complexity is actually free, in a way. The development of additive manufacturing resembles the one of mobile phones. 15 years ago, mobile phones used to look like that. They were slightly connected, they were mostly hardware, and they run only a couple of apps. For example, 3310 introduced calculator. Whoa, high tech. And also Snake 2, it was good. And look at our phones now, smartphones. It's all about applications. It's not anymore about connectivity. It's not about hardware that much. During last couple of years, in additive manufacturing, we have seen a rapid development in the technology, but still, we are in the 3310 phase of the technology itself. This means, since we are going up really steeply, that we will achieve the smartphone, the iPhone of additive manufacturing quite soon. We have approximately 5 years' time. Since the printers, the machines, they're nowadays like 3310, slightly connected, only few data gathering and data like collecting methods there, and they are mostly like isolated machines instead of ecosystem, which they are going towards. Yeah. This is going to end up in a situation what we called features wars. It means that since we are shifting in the digital design of manufacturing, and since everybody is available to use these kind of, for example, cloud computing, cloud softwares, the tools are everywhere. Everyone can utilize them. So that it's only a matter of the idea behind it. It's only a matter about the quality of the actual model of your product. It can be digital twin, whatever, but it has been really good. And the ability to translate decades of physical product expertise into digital data and the features, together with the best view about what is actually needed in the market. It will decide who will win and who will lose. It's not all about anymore about physical manufacturing. It's virtual. Yeah, and we will use and we will utilize huge amounts of data to build those perfect models, perfect version of our products. And who will be the people who will build those models and provide that data? It's you. CAE, CFD, FAM, CAD modeling, topological optimization, whatever, you name it. They are the building blocks of this perfect model. And this is the moment where additive manufacturing comes along. Because now you have the perfect model, the product like it should be. You have two options now. Whether you manufacture it and tune it down just to meet the requirements set to you by the conventional manufacturing methods. There is quite much limitations. Or you build, you grow almost the optimal, almost the perfect version of your product, and print, 3D print it as it was designed, and it was supposed to be. It's a paradigm shift. It's a totally different approach. Okay, there is many challenges to be solved before we enter this phase. But as I said, we have a couple of years' time. It's not that much. We must start now. And when it starts, it has already started. We are in that boat. And there is a tidal wave coming. We want to prepare for that. Ooh. Now it's getting more concrete. Okay, just a quick example by General Motors. It's a really simple part which is found in almost every car. It's a seatbelt bracket. There is the conventional version made by CAD, maybe some FEM modeling or like a validation, and that's it. It's ready. But in the right, you see the generatively designed version. Not a single line in that model is modeled or drawn by human. It's only based on the input data, only based on the functionality of that part, of that particular part, of those particular forces and stresses it has to withstand. So it's not this kind of general like a trade-off between manufacturability and functionality. It's almost perfect. And as you can see, it's quite much better also than the original part. Also, what if we want to make some changes to the design? Not a problem. These were all based on the same model. And by altering the input data, for example, forces, we can put it in a tank instead of like a Nissan Micra. It's definitely a different part, but it has the same functionality. It has been tuned for that particular situation. It's called mass customization. And as I said, by additive manufacturing, you can actually build this with the same price, every single piece. It doesn't matter how many different versions you create. Okay, it was really high level things, really like flying high stuff, and it's easy to get distracted about all the fancy tools and all the fancy terms. We call them buzzwords. So any ape can reach for a banana, but only human can reach for the stars. And in the context of additive manufacturing and the design for additive manufacturing, the buzzwords are the banana. You just think that, okay, by taking this banana, I will be like the world-class player. But it's not like that. And that's what we call the smart approach. It's understanding the purpose, understanding the functionality, and it's not dependent on the tools. It's not about the tools. It's not about the technology. It's about the purpose. We want to do that, and we want to make it the best way it can be done. Also saying that, yeah, 3D printing, it's not for us. Maybe you don't understand it well enough. You can't say that like that. I will show you why. Yeah, also this example here. Big thinking, more than top technology. For me, it's the same thing that, like buying the most expensive sound system there is in the market. And then you decide that, okay, I want to put it in a test. I will want to hear how does it sound like to play a song through that system. And then you choose David Hasselhoff's song. And what do you think that comes out? It's still David Hasselhoff. So it's not about the technology, it's only an amplifier. You have to rely on that original idea. Roof is not the limit, sky is. This is for understanding that even though, as I said, in additive manufacturing, we still have some limitations. For example, the build chamber is relatively limited. It's, depending on the system, it's quite small currently. But it doesn't mean necessarily that we cannot use it to produce something big. So a smart approach is also taking the focus of the final product and focusing instead on the functionality. Again, the purpose. And I bet that almost every one of your businesses, there is at least some pieces which are craving for additive manufacturing. Okay, now we go in the concrete level, factory floor. We had a problem. Eric, can you please bring that? I forgot to bring that example. Yeah, we had a problem. We wanted to measure the quality of the machining in that huge engine block. The perpendicularity between this face and this surface. It's relatively simple task to do. And again, you see the scale. This is actually even the smaller version of that same problem. In this case, this hole diameter is 46 centimeters, something around this. It's huge. Can you use additive manufacturing? Is it too small? No, it's not too small. The conventional way of solving this problem was this. It's made of machined aluminum. It has been welded. There is much of really, really accurate machining to be done to achieve this product. There has been some welded steel structures also, and still the function is to hold dial gauge, the clock, here, and to measure the perpendicularity of this surface to what is here. It was 10,000 euros. For decades, it has been the same. We have multiple of these same designs. It's really, really expensive. Also, it's really slow to manufacture, a couple of months, and it's clumsy. It's really clumsy. 23 kilograms. We need a crane to lift that from cylinder to cylinder. It doesn't work. But instead, using smart approach, we came up with this solution. These have the exact same functionality than the conventional one, but as you can see, we have dropped down 20 kilograms of mass. And also 90%, 9,000 euros of manufacturing costs. And still, we have the dial gauge here. It has been connected to the laptop, so we can utilize the data after it. It's already digital. It's good. And the weight is around 3 kilograms. As you can see, I'm not that strong. I can lift it. So, in comparison, things using additive manufacturing and utilizing the freedom in a smart way, they can get disruptive. You don't see very often these kind of figures. You see maybe 5%. It's still quite much, but 90%. Can you believe it? And it's really working. It's not a problem, because we only choose to 3D print only these joints here to mass customize them. And then we use standard carbon fiber tube, standard bolts and nuts, standard parts, as many as possible, and still we can achieve a goal like this. Okay, it all comes down to money, and everybody is interested about it. Here's a decoy. It's a metaphor of money. So, this is our implementation plan for additive manufacturing inside Wärtsilä company. In the first stage, you can see, this is our tool case here. This is our first step in the whole journey. And already here, we have realized almost 20,000 of savings in one single application. So how many are these kind of applications? Tens, maybe hundreds. It can be nasty. It's going to be big, I promise. And also the payback time of the machine. We utilized Markforged Mark II. It's carbon fiber composite printer, and we were able to pay it back by printing 2 of these. We got the machine in, I think it was May or June 2018, and it's already paid back. So this is like the payback arrow, and when you go higher in levels, of course, it's gonna take a little bit more time, but you can make really, really big savings there. And okay, this is mostly manual. We used only just standard tools, designing tools. But the importance of data handling, data analytics, CAE, all of the stuff you do, material modeling, whatever, it's increasing here. Because here, we are taking all of the performance out of the additive manufacturing. And these are the problems that cannot be solved using these manual methods anymore. As you noticed in the generative design case, there is 15 different models, and they can be designed like simultaneously, parallel. And what else? Yeah, this is the feature walls stage. And as we can see, based on the maturity of 3D printing technology itself, it's an enabler, it's a gate. So that our gate is actually get pretty much bigger, pretty much cheaper, so that we must be ready before this gate opens. And it's not so far away. It's only 3 to 5 years from now on. The processes will develop so fast. They will become ecosystems instead of machines, instead of 3310 Nokia phones they are today. They will become maybe this smartphone. Okay, please come to see us upstairs. There is a 3DC booth. We are also there with Wärtsilä and Mark Forge. I will be there from today, at least, from 3 to 4. Please come to discuss about the things which were interesting about this presentation. And what else? Please come. Let's have a discussion. And so for the last, remember, let's not throw all our money and resources away and end up in a David Hasselhoff situation, but let's utilize the design freedom of additive manufacturing in a smart way instead and be the masters.
I had everything that money could buy, but freedom I had none.